and you get the exact dollar amount to the cent from Bing, right? So it's exactly 40 billion that he owned in 2009. In this case, population of Los Angeles. From Google, you get a chart, right? So you get to see how the population changed over time, which is fairly nice. Facebook graph search. I already mentioned that Facebook collects a lot of data from the web. They also have their own private graph, which for them primarily consists of users and their connections, right? So the one part of this graph is the social graph, right, as they call it. The other part of this graph is built from what people like, right? So you have these Facebook like buttons all over the web. Whenever someone clicks a like button on the web, they make a connection in the graph from the user to the entity that the user liked. I will explain how they know what that entity is, but for now it's enough to know that they have this graph which consists of entities and topics, right? Here the query is, so again, they have this search box, right? Very much like a search engine would, in fact. And here you can construct all kinds of fairly complex queries. They have a search assistance tool, which also helps you to construct these queries. So you start typing, this thing drops down and suggests you possible queries. So these are sort of pre-programmed, if you will. Here you're looking for restaurants near Los Angeles, liked by my friends who blah, 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 blah. You can continue the query as you want, and you can make it as complex as you want it to be. Here are the results, right? And what you see is also some kind of faceted search, right? This suggests you that these are not just web pages, but they actually understand the fact that these are restaurants, right? So you can search on the type of the restaurant, on where is it, and so on and so on. I mentioned fairly complex queries that require computation. This is one engine called Wolfram Alpha, which does just that. So you can essentially combine searching with computations on the results, right? And again, this is based on a knowledge base. In this case, it's again a private knowledge base that they curate themselves. It's not open to the public, but they integrate DBpedia as well as a number of other information sources, public statistics, and so on. So you can make fairly complex queries. For example, the average salary of mathematicians, and then they compute it and they chart it for you. Right? So these are fairly complex queries that they can answer. All right, another dimension that I wanted to introduce is situational searches, if you will, or contextual searches. In this case, there might not even be a query, right? The query is either you or where you are, right? This might have been called traditionally recommendations, but I think the line between information retrieval and recommendations, or search and recommendations, is sort of disappearing. In this case, you have a system which is built into your TV set. There's a product from Yahoo, it's called Connected TV. What it does is that it monitors what you're watching on TV, right? So, bit Big Brother, but it knows inside of the TV at least what you're watching by recognizing the sound print, the sound that is playing on the TV, and then it gives you all kinds of related items, right? So in this case, you're watching a boxing game. It gives you an ability to vote for who do you think is going to win that game. You might not think of this as search, but it is search, right? It is search that is running continuously, right, inside your TV set and recommending you things. A similar product that we have is a phone application. It's a mobile application. It's called Into Now, and uses very much the same technology to recognize the sound that is coming out from the TV. So much like Shazam or similar products, it takes a fingerprint of the sound, it sends it to a server for recognition, and then it shows you again, related information, this time on your phone. So this is what they call a second screen experience because you have two screens, right? You have your TV as well as you're holding your phone or your tablet while you're watching TV. It connects you to people who are watching the same show, so it has all these social elements and built in as well. All right. Yet another setting where sort of search is becoming more important, and in particular semantic search is on the mobile, and it is partly because the limitations of the mobile, right? So the screen is much smaller, hence the keyboard is much smaller, right? You're typing now on your screen. You're very likely to make mistakes typing, so there's a larger emphasis on voice, right? On actually speaking to your phone. So I'm sure many of you at least heard of Apple's Siri, which they style as a digital assistant, right? So as a kind of intelligent agent which serves your every wish, if you will, right? I guess that is a bit difficult to live up to, but what they really have is a kind of question answering system, right? So you can essentially talk to this system, say your question, speak your question into it, and then it will try to interpret the question as well as provide a direct answer, right? So here, the search is not over documents anymore. It actually consults a number of backend knowledge bases, a number of backend services. A couple of them actually coming from Yahoo, finance and sports, for example, stock quotes and sports results. They also have a partnership with Wolfram Alpha, so actually some of the results come from Wolfram Alpha. If you will, what they have is a federated search engine, right, that serves results from multiple backends. It has some interactive features in the sense that it can also do task completion. You can ask it to make an appointment in your calendar, right? So it has an understanding of tasks as well. And Google is doing something similar in Google Now on Android. Conversational search is part of this picture. Search becomes conversational when there is actual dialogue going on, right? So this is what is called dialogue systems in the literature. I guess the marketing term is conversational search. This is something that Google started to speak about a couple of weeks ago. Interestingly, not so much in the mobile context, but in the web search context. So, you have an initial query like, how old is Barack Obama? Well, Barack Obama is 51 years old, apparently, or was when I did this query. But now you can say, how tall is he, right? I don't think this is a big magic, but they managed to realize that he refers to Barack Obama, right? So there's some co-reference resolution there, and they can give you the height of Barack Obama as a follow-up. And now you can say who's his wife, and you can imagine, again, they understand that it's Barack Obama's spouse, in this case that we're talking about, who is Michelle Obama. All right, we are working on related technologies to this in a European project called Parlance. This goes a bit further. It combines voice and conversations, in the sense that this is a system that allows you to have a dialogue around a set of objects in a particular domain. So it has a knowledge base inside. The demonstrator that is currently running is about restaurants. So it has a list of restaurants. It knows about the area, the price range, and the type of cuisine that is served in those restaurants. And what you can do is have a conversation with the system, right? So it's a restaurant recommender, and you can search for restaurants, right? So now if you could play the video, we have a video of how this system works. The video is a bit grainy, but hopefully you get the sound of it. We need the sound though. Can we go back to the beginning? So user is asking, can you give me a Chinese restaurant? All right. So I hope it gave you an idea of what this system does. What you've been seeing on the screen, you can look at this video later. The online version is slightly higher quality. What you've seen on the screen is the system producing interpretations, possible interpretations of what the user just said, right? In terms of what they call dialogue acts, right? So these are snippets of a structured query in the sense that, for example, did the user refer to the price range? And if the user referred to the price range, did the user just say cheap, medium, or expensive, right? So trying to fit what the user just said into these attributes and their possible values, right? So this is the spoken language understanding component in the system, right? This is the second step. Obviously, you first have to need to get some understanding of what the words might have been that the user has spoken, right? So trying to transcribe the text in a way that might be probabilistic as well, and then doing this semantic interpretation, right? So then trying to translate what the user said to these parts of a structured query. And then the query is run, right? So then you retrieve some restaurant. And at that point, the system goes back to the user and says, you just said you want a cheap Chinese restaurant in the middle of the town, but there are no cheap Chinese restaurants in the middle of the town. Do you want to go further from the center of the town, or you want Japanese instead, right? So now the system can sort of intelligently make a conversation and offer suggestions, also in the case nothing is found, right? So there's this interactive management component that handles this logic of the conversation. And then, to verbalize these things, they use technology, natural language generation, and text-to-speech that actually speaks out the result. Okay, and some of these components you can look at the Parlance project, European project. Some of these components in the project are free or open source or both, and available for research. Some components are not. There are certainly commercial alternatives from a company called Nuance, which is also providing the technology for Apple's Siri. All right, so what is semantic search? Well, you might have some intuitions by now. But I'll take you back to the basics again, right? So, and the basics are really this. You have to think like the machine. You have to think what it's like to be a machine to understand why is this difficult or where the challenge is. So what is it like to be a machine? Well, user thinks of a concept, let's say Roy, right, our favorite example. Right? And then this user writes down a few words, right? This is, in some relationship to the intent, but not necessarily exact. We already mentioned that. Types it into the computer. Computer has some choices, some pages to choose from. Chooses some pages and then has to order them, right? Sort them in some way, and then give a result. Right? But this is not really what the computer sees. What the computer sees is more like this, right? There have been some symbols coming in. there were some symbols in some files, right? We match the symbols user typed in to the symbols in the files, in the documents, right? And we have to give back something, right? And this is, of course, a considerably more difficult view of the problem, right? But this is the way you have to think of it, right? Computers don't understand. They don't understand language. They manipulate symbols. They see streams of characters. They might see the boundaries between the streams of characters, but even that is difficult because you have to tell them that space is a separator, right, in the stream of characters, right? And everything else is very, very difficult for the machine, right? Everything else needs to be taught. It doesn't come cheap. So this is really basic. This is why information retrieval is difficult, right? Now, semantic search is one approach to addressing this problem, right? Possibly not the only approach, but one approach. And here the idea is that we try to represent both the user intent as well as the resources that we need to rank using some kind of semantic representation, using what we'll call a semantic model, some kind of higher level representation of the user intent. And then, of course, semantic search engine is only a semantic search engine if it really uses this conceptual structure somewhere, either in matching, either in ranking, or in result presentation, right? At one of these three stages of the search process. Right? It is often a hybrid. You might think that this only relates to knowledge bases and searching over knowledge bases or searching over databases. This is often a hybrid. Often we have situations where we have documents with metadata. We'll come back to that. So you've already seen yesterday various ways of putting metadata inside HTML. But you can think of email, which comes with a header, right? That's metadata. This is data about the document, right? But sometimes it's pure data retrieval. In this case, we're essentially still searching text, but this is text that is attached to the data, that's inside the data, right? It's text inside the cells of a table, or it's text attached to labels of a node in a graph, and so on and so on. It is a very diverse field. It is very hard to summarize because of that, because of the variety of approaches that people take, and also the different settings, right? So I'll show you where some of this variety comes from, but it is often a combination of approaches from different fields, which also makes this field very hard to track, very hard to follow. I wanted to give sort of a very brief note about this notion of explicit versus implicit semantics. There are methods in information retrieval like latent semantic analysis, which sort of try to create semantics bottom up, right? Try to create some kind of representation of the document that is using a lower number of dimensions than all the vocabulary, right? Trying to represent the text in terms of coarser grained topics that are mined from the data, that are extracted from the data. This is something I would call implicit semantics, in the sense that this comes directly from the corpus. It's a very accurate and faithful representation of the corpus itself, but it's not necessarily transferable as knowledge, right? There's a problem of labeling these clusters that emerge from the data, or these topics that emerge from the data. And this is not an explicit representation, in the sense that you don't actually know what this cluster stands for. You still need to interpret what those clusters in your data stand for. So we'll not talk about these kind of approaches under semantic search because of this, because they don't deal with explicit semantics. Or at least I'll ignore them for the rest of this presentation. All right, so semantic models. So semantics is concerned with the meaning of the resources that are made available for search. And there are two broad categories of semantic models, right? One is linguistic models, So this is understanding text in terms of linguistic structures. I'll show you some examples of what this means. But essentially, everything we know about language from, let's say, linguistics, right? So theories of language, right? So people, for decades, possibly centuries, have tried to come up with ideas on how language is constructed, right? In the earlier days, grammars, right? So trying to produce, a machine, an automaton, or a set of rules that would explain, for example, how English sentences are constructed. These days, that's mostly done, again, with machine learning, but nevertheless, the same idea, some kind of model of how words in a sentence, for example, relate to each other, right? And then also trying to create representations of words in the sense of clusters of words, right? So different words, for example, that refer to the same meaning, right? And then creating some kind of, broader, narrow relationships or synonymy relationships and so on that relate these clusters of words that relate to similar meanings. Okay, so these are linguistic models. I'll give you some examples. I will also talk more about conceptual models, and these are models that go not from language but start from representing the world, right? The root here is really ontology and knowledge representation. Ontology, the word refers to sort of an ancient in the sense of ancient Greek philosophical concept, right? Epistemology, right? Trying to understand the world around us and trying to come up with representations of the world, right? Trying to write down what are all the things in the world, if you will, and how they relate to each other, creating this conceptual map of the world. Right? Now, ontologies, as we talk about them today, are less ambitious in the sense that ontologies on the web just try to model a small part of the world, right? Try to model, the domain of recipes or the domain of businesses, right? But very much start with writing down, right? What are the elements in the domain and how they relate to each other? Sure. So I think, I would not say entity names, I would say concepts, because entity names really says, there might be multiple names to refer to the same thing, right? I would say more the conceptual object, right? The thing that exists in the world, right? Going back to the Jim Handler example, right? There's only one Jim Handler, right? There might be multiple names to refer to it, but that James Handler would be represented by a single node, right? Which would have multiple names attached to it, right? So these kind of representations that really try to look at what is out there, right? In some world, right? I'm not going to get into the philosophical debates about whether this world exists or we all see different worlds or how they relate to each other. Let's just say there's a world out there, and we're trying to model that. We're trying to capture that for the computer, right? We're trying to say to the computer, these are the things out there. These two things are related. Those two things are not related, right? And those two things are related this way, right? So that's the idea. These are conceptual models. All right. Now, if you want a process view of sort of semantic search, well, we have either structured resources, entity graphs, databases, or we have documents which are linked to each other, right? So, for example, in hypertext case, now we're representing these in some kind of semantic model that I mentioned. So we get some kind of other representation of the collection. And then we try to exploit this semantic model at some part of the retrieval process, either in understanding our queries, understanding our in processing our queries, matching between the query and the resources or documents, in giving presentations, in collecting feedback, in some step of the search process. Okay, that's the idea. Mm-hmm. Very good question. This is what we're going to treat next. All right. Before we get to that, I still want to situate, semantic search as a research field that is very much drawing from other fields, information retrieval, databases, and knowledge representation in particular. Compared to information retrieval, you might have intuited by now, information retrieval has much more lightweight representations of text, of documents. It works well for some of the things. It doesn't work well for some other things. Again, I've showed you examples. It's designed for large-scale processing, which is not necessarily a concern, for example, in some other fields, but certainly information retrieval because already large collections exist. In databases, knowledge-based systems, semantic web, up to now, right before, let's say, semantic search, the focus has been more on expert users supporting very, very complex queries, the kind of Sparkle queries that I mentioned, and matching them exactly, right? So if you have a Sparkle query and if you have a knowledge base, you solve that query, you get all the items that match that query, but typically you're not concerned with ranking, right? So just like in databases, there are some works on ranking, but it's really secondary. Primarily, they are concerned about matching, right? So how do you match the structured query to the data? And then ranking is really a secondary topic to that. Okay? And of course, if you're doing something more complex, you're going to run into different limitations in scalability. So that is certainly the case. The more complex your queries get, the more complex your query language gets, the more difficult it will be to give fast results, fast answers. All right, I already mentioned that it's a research field that combines many things, and therefore it's hard to follow. Really, the best way to follow up after this lecture and after this entire summer school when you get home, and hopefully you have more time, is to look at specialized workshops that have been organized in this field. We've been involved in organizing some of them. There's been a workshop series at SICM which is called Exploiting Picture, right? So research, as it is unfortunately very fragmented into different communities that go to different conferences and in general don't talk to each other, right? They publish in different journals, visit different venues, don't necessarily read each other's papers. That's a bit of a problem when you have such an interdisciplinary field as semantic search. Related, of course, other attempts to use semantic models on different data, right? So, for example, XML retrieval, right? When XML was popular back in the day, right? People have worked on XML retrieval in particular and exploiting then, particular characteristics of XML data, right? Which is an interesting, kind of semi-structured data format, right? Where you have a tree, but it's a tree that is the tree structure of the document, right? That is the structure that maps of how the document is divided into chapters and sections and paragraphs, right? Keyword search in databases, I mentioned already, this is sort of a small, almost niche part of database literature. And in fact, there's no standard evaluation for keyword search in databases. There are some interesting papers to read, though. And then natural language retrieval is focusing more on the linguistic models, right? So focusing on what we can do with language retrieval. All right, now what I'm going to do in the following is really just walk you through the process again. So this is just a different representation of what a search engine does, which by now you must be intimately familiar with. So we're going to talk about data. We're going to talk about how to collect data, how to index data, talk about query interpretation, matching, ranking, and then in the end, result presentation. All right, so let's start with data, and hopefully, we can cover this in the next half an hour, and that will take us to the first break. I gave you already the idea that semantic data is really something that that is not just the raw data, but it's something that is interpreted according to some kind of linguistic or conceptual model. And therefore, it becomes semantic data. So I'll use this terminology to refer to the already interpreted data. The raw data itself might be textual, might be structured, or might be some hybrid of the two. I'll give examples of this. And we already mentioned that the semantic model itself might be some kind of linguistic model. For example, WordNet, right? So WordNet is, for example, a representation of the English language. There are different editions for different languages, but for the English language, right, it gives you a dictionary. It gives you all the words in the language, as well as their senses, right? So I mentioned that that there might be multiple words expressing the same sense, and it gives you linguistic relations between them, broader, narrower, synonyms, antonyms, all this kind of stuff. And then conceptual resources, I'll show you some examples as well of ontologies that could be particularly interesting in a semantic search context. So first, the difference between linguistic and conceptual representations, I'll try to explain it in a sort of graphical form. So let's say you have a piece of text, and it says Pablo Picasso was born in Malaga, Spain. And so this is just expresses that painter Pablo Picasso was born in this Spanish city. But what information retrieval does is, it treats this as a sequence of characters, right? Tries to break it up, so at least it tries to understand the text at the level of where to separate the tokens. It throws them into the cauldron, into one big bag of words, right? But it's still just that, right? It's still just sequences of characters, right? Now what we call natural language processing, or part of natural language processing, tries to reconstruct some of the language structures that were behind this sentence, and that might have been in the user's head, the language speaking portion of the user's head that produced this sentence. Very primitive type of analysis that you can